Hi everyone, welcome.
Welcome back.
Yes, today's Friday, and on Fridays we are having our workshop series. And yeah, thank you for being here today.
Mhm. Yes, today we have a special workshop with many speakers, so that we are going to do some afterwards. But we will start. So, for the people that are following us since the beginning, this part can be a bit boring because it's repetitive. But for the new ones, we want to present who we are and what we are building. So me and Felipe, we met at Phenom 2020 in Tucson last February, before the pandemic, and we decided that it was necessary to build a community that can provide support for beginners, and also like making that can also be an opportunity to create networks between people working within plant phenomics. So this platform is called PhenomeForce. It's very new, but we have already many people that are being part of this, and this we are very happy of it. So if you want to know more about us, we have a website that you can visit. We also have a Twitter account, so you can follow us there. And we also are building a Slack workplace. So if you want to be part of it, you can just mail us at phenomeforce@gmail.com. So far, I want just to say that, so for the people that are not familiar with Slack, it's a very cool app because it allows you to enter in the different channels based on your interest, and also to contact directly the person that you want to work with. So for example, Felipe was one of the first speakers, and if you have questions on his package, you can contact him directly there.
Yeah.
Um,
Just can I add one thing?
yes.
So guys, if you are new here and didn't subscribe yet in our channel here on YouTube, so go
Mhm.
ahead and subscribe right here, because then you can follow all activities that we are doing. We are having workshops actually every Friday from the next 9 Fridays, I guess. And after these, we are continuing posting new videos, and you guys can continue following our activities and also helping us to share this information with other people.
Mhm.
So also that's important. Give us the like here too in the videos, and share this, all this information with other group, because our main idea, as Anna said, is help and share. Right?
Yeah. Also, like, so we are starting. This is our first event, which is this series of workshop that we want to promote tools for data analysis in plant phenomics, because we know is probably the most challenging part in when you are doing plant phenotyping. But this is just the first event that we are making, and we are thinking already to what we are going to do afterwards. If you have any idea or suggestion, you can contact us, and we are very happy to receive feedbacks or new idea or suggestion. So we are. So I'm Anita Marrano. I'm a postdoc at University of Massachusetts Boston, and Felipe Matias. Felipe is a postdoc at University of Wisconsin Madison. So this workshop series was promoted by the MPPN, and we thank Jennifer Clark and Christian Top to help us for their support. And also, like, this workshop has been possible thanks to the support from the Midwest Big Data Hub. We also want to thank Noah Falgren because he helped us with all the technical issues, especially building the binder environments that have been used in the previous workshop, and they will also be used afterwards. So today is a kind of a different workshop because so we try to build a binder environment, but there are some inconsistency or incompatibilities between the R version, the one that is available on binder, and the one that is needed for the R package. So for this workshop, so there are two options. You can go to one of the link of the app, which is called MrBean. And here you will see, so like this one, and then you can work on the app itself. However, the server, we don't know if the server can support many people. So we encourage, if you have experience in R, to download the package on your laptop and work on it. So we are also here providing at the bottom 2 links where you can download the R packet, the R software, and also the R Studio, which is a kind of platform that make easy to program in R. And also, like, you can get more information about the app that we are using at the GitHub link that we are providing here. So part of this workshop also include ASRAM, which is a licensed program that is widely used in plant breeding. So it's a licensed program, but if you are a PhD student or a master student, you can have 1 year free license. If you want to also like have information on other kind of license, you can contact Salvador Gezan, which is one of the speaker of today, and here you have his email for asking more information. But now Philip is gonna explain more about like how to install the package, and he's going also to introduce the speakers of today.
Yeah, so guys, actually super easy. This interface that we are seeing here is the R Studio. We already talked about R Studio in other workshop here, so go there and check it. And it's super basically. Here is some of the possibilities for installing the package. We are using DevTools and pushing the information directly from the GitHub account from Johan. And probably he's gonna talk better about that. And then after this, you just, you already have the package there, just use the library and then run app. It's gonna open, the next slide. It's gonna open a Shine application, which to me it's a fantastic tool now. I do have some experience doing Shine apps, and super fun because you can change colors and you can choose any detail there, and super simple. And also pretty intuitive, and it's a click point. So basically the people who are programming in R, but actually using click point interface, which is super, super nice. And so after you run app, supposed to open a window or an application like this one that you're looking right now.
Mm-hmm.
So with this, I wanna introduce our next speakers, which we are really happy to have them here. Today is a little bit different to the other workshops because we have a group speaking. And so we have Ana Maria from North Dakota State. Also, we have Salvador Grace, which is a geneticist and statistician consultant from VSNI. And also, Johan also is a statistician from CIAT. So it's really, really, really nice to have you guys here. And they're going to talk about MrBean, which is the Shine tool they're developing together in this institutions group, which we should work more on that, right?
Yes.
And also, just one message, you know, we are many people here and we are talking using internet, using many devices, and something, you know, these things can go wrong. And then if we lose the connection, stay there, wait, we are gonna do our best to come back and continue the workshop, okay?
Also, I want to say that, so because we already received some emails, so if you have any problem in installing the package, or so we cannot provide support during the workshop because of course we are busy and the workshop in general is 1-2 hours, but the YouTube video will be there, so you can always rewatch the workshop whenever you want. But also, like, you can contact the speakers and they will, I'm sure they will provide you with more details on how to solve issues and installation. So feel free to contact us and we will put you in contact with them to solve. So I guess, so it's a very busy morning because we have 3 speakers. So I guess the first one will be Anna. Yes, I add you to the stream. I will stop sharing. So Anna, if you want to start sharing your PPT, and then we will leave you. Oh, also I want to say that you can post your comments on the workshop live, and we will stop the speakers to ask them to answer your question whenever you want.
Okay.
And so good luck, guys, and have fun.
Yes.
Well, thank you very much, Ana Rita and Felipe. And for everyone that is streaming live, welcome. My name is Anna Heilman, and we would like to introduce you to MrBean, which is a beautiful app that it will help you with the analysis of data, especially if you are a plant scientist or a plant breeder and are interested into looking at more of your data and do analysis, especially or multi-environmental trial analysis. So some of the topics that we are going to be covering today is some of the challenges that we face in agriculture and how we can have some of these analytical solutions to help us. We will tell you about where to find MrBean. Some of you have already received that information, but we want to clarify that. We are going to talk about the creation of MrBean, how it was conceived, what can MrBean do for you. Then we will have Salvador Gezan talking about the context of the quantitative genetic analysis and what can be done. Why are we feeding the linear mixed models? And then we will jump into the session with Johan. That will be more kind of like how do we use MrBean for the spatial analysis? And then we will get back to Salvador, and he will talk to us about how do we do analysis for multi-environmental trials. Finally, in that sense, we are going to be having the first kind of like the demo on the single site analysis, and then the multi-environmental trial, kind of like understanding the variance components and the variance structures, then the multi-environmental trial analysis part, and then we are going to continue with the closing remarks and questions. So as I said, we have some challenges in agriculture. Some of them are based on, like economical problems or the access to technology or the access to automated solutions that can help us to minimize the time that we spend doing analysis ad hoc. So here's where we have MrBean being an analytical solution that will help plant breeders to automate their data. And with that being said, like one key activity in plant breeding is to accurately predict the genetic potential of the genotypes that are coming out of that pipeline. So then sometimes they are having really big trials, and then to be able to do the analysis spatially, knowing coding and kind of like producing automated solutions can be a challenge for a breeder or for a team if they don't have the right people with the right set of skills. So with that being said, I just want to let you know where to find MrBean. So MrBean can be downloaded directly from mrpackages.netlify.app/MrBean. And then you can also go to the GitHub website, and in that, I would like to let you know that Johan Aparicio is my colleague who developed the application MrBean. He has been kind of like the mastermind behind it. And with that being said, you can just see in here that we send some instructions. We would like to produce the book that will go accompanying this package. Now, the creation of MrBean. Johan, that is in SIAT, was having kind of like a lot of people coming to him, kind of like asking him like, hey, we need to analyze this data. And then as part of like that process, I also met him and I met Salvador, and I was like, well, we need to make some automated solutions, kind of like we'll be able to help the breeders so they can click, and then just do their analysis. So then that was part of like the planning process, thinking about how it was going to be made. And then once that happened, like the production started going on, especially like we met last year, but then we started working this year pretty much during the pandemic. And then that's when kind of like it speed up a little bit more of the production of the multi-environmental trial analysis in there, and then the incorporation of the AS Remel side. And then now we are implementing the tool. We want to reach as many people as possible. So what can MrBean do for you? it has a platform that allows you to import data, or it allows you to connect also through an API to BMS. Or if you have another database type of system, you can also kind of like work on the API build. It has a section of descriptive statistics, so you can see your data for the quality assurance quality analysis. It also has the single site, the spatial analysis. You can do the analysis with spots. Then there is also the site by site or the multiple site analysis. Like I do an analysis at a time for each location that you include in there, using spots. There is the other part or the other module that it does the analysis of multiple traits at a time using spots. And now we get into the option that users can use the ASREML. And then there is a single site spatial analysis. And then there are several components in there that it also kind of like will help you in the analysis of unreplicated and augmented spatial designs. And then we have, for those users that are going to be more into the advanced users, we have a model selector that it will help you to define which would be the best model that explains your data. And then with ASREML, we have the multi-environment trial analysis, and which is super cool. I really like that. And finally, we have a portion that contains the LME4, and that's for the kind of like a traditional analysis. And then you can do your analysis, like if it's an RCVD, you can do an RCVD analysis, CRD, and so on. So with that being said, I'm going to pass the ball to my colleague, Salvador Gezan.
We can listen you.
Yeah, Salvador, you are unmuted.
Yeah, okay.
Yeah, good.
Tiny entire screen. So let me just share my, imagine you can see my presentation there.
Not yet.
Okay. Okay. So Anna was telling us came up. All of this comes into a context of analysis, and having issues with
Salvador,
users was something used.
just a second. We are having a connection with the internet right now. Yeah, let's see if can you hear me? Can you hear me?
Can you hear me?
Yes.
Okay. Here you can see my screen. About of MrBean, and the need really arises from having readers who are
Salvador, just a second. Try to turn off your camera.
Yeah.
Maybe we got better connection.
Or you can also try to exit and connect it again.
Yeah.
Mm-hmm.
So maybe the internet side of it.
Yes. You're talking like a robot. It's super cool though.
Okay. So let me try this, please. So maybe one of the things we need to do is to stop my my camera.
Yeah, maybe Johan would start until you get better connection. What do you think about that? Johan?
Yeah, okay.
Yeah, could you start?
Yeah, I can do it.
Awesome.
So thank you, everyone. Thank you for being here today. I'm really happy to be here. I don't know if Salvador now has a better connection.
Let's see.
Yeah, let's see.
You have better connection now?
I'll
Seems
have to get off and get in again. So
Yeah, now
I
it's
think you
better.
should proceed, Johan.
No,
okay.
I think now
It's
I
working
think it's
properly.
working now.
Okay. Okay, let me stop my camera and
No.
share my screen again.
Okay. Let's try. Let's try. Sienna, we are learning a lot though.
Yeah. Well,
Okay.
it's normal.
Exactly.
With the,
Now, I
yeah,
wonder
with
if
the
you can
internet
see my screen
connection.
now.
Yeah, it's
Yes.
okay. And we can also hear you very well, I think, better than before. So
Yeah.
go ahead.
Okay. So our goal is to use the latest statistical technology that is available for us, and also using what it sounds models to fit, without making too many mistakes, without getting into things that are too complicated, but in a way that allows them to do the analysis on their own. That's our main target. On the same lines, it's all of us who do some of the statistical analysis here and there, and we want something that might be at points easier to do, more automatic. We can get it done in an hour or so without having to recode everything. So the core of all of this is linear mixed models, and linear mixed models is where we want to get with MrBean and other things that we extend in the future. And we will
Salvador.
talk about spatial analysis and multi-environmental trials, but mixed models is in all our quantitative analysis, also multi-trait analysis, when you're with very degree, some
Salvador,
form of
excuse me.
correlations. With the genomic data, we do something similar. We also have correlations there. And then we have repeated.
Salvador, can you hear me?
Yes.
Yeah, you talk like a robot again. Let's try start with Johan,
Okay.
and then we try to come back. Okay?
Yeah.
Yeah, thank you.
No problem.
Okay, thank you. So I'm going to share my screen and let me know if you can see it. Entire screen. Okay. So again, hi everyone. I hope you are having a good time. So now I'm going to explain you a little bit. And basically, what Salvador was saying is like the introduction about the theory about mixed models, and also related with the spatial analysis and what we can do with linear mixed models. But I will leave this like this. But the only thing that I wanted to mention is that we are going to focus on the spatial analysis. So in agriculture, so we are going to to think that we have our experimental units, our plots are our experimental units, and each experimental unit has spatial coordinates. That means that is the x coordinates, that is the column, and the row coordinates in the field. And when we have this, we can now like analyze our information using different approaches. And this is, for example, we can use different kind of patterns, I would say, like polynomial functions, splines, random effects for row and column coordinates. And this one for patches effects, we can incorporate incomplete blocks on, and also the correlation, autoregressive correlation among the residuals. And this is something that you can do using ASRemel. This package allows you to incorporate different structures, and also for residuals and for your random effects. So this is what I wanted to say. This is the spatial correlation that use ASRemel for modeling the spatial variation in the field. So I'm going to jump to MrBean. So I only want to mention that you can put the MrBean as a desktop app. So you don't need even to open R. Only what you have to do is to, later I can show you how to put MrBean as a desktop. And this is what MrBean looks like. This is the home page of MrBean. This is on the left side, you can find the modules that MrBean has. Data, spats, analysis. This is the approach that proposed Maria Soxe, and the methodology of the same modeling spatial variation by using the second approach, that is using ASRMLR, incorporating like correlation, autoregressive correlation among the residuals. And this is the two-stage approach that we are using for analyzing multi-environmental trials. This is something for traditional designs, that is basically for analyze randomized complete block designs, and CRD designs, but the basis of the traditional designs, I would say. And okay, on this side, you can find like related with the first approach that I mentioned, SPATS analysis using splines. You can find more information about the package that we are using. This was proposed by Maria Soxe. You can find more information in there. And also this one is for ASRML. This is the manual for the version number 4. And you can find more information about how to write some code in R if you want. And yeah, about the structures, about how to analyze information. And if you want to go there, you can go. And this is the other package that we use for analyzing like the traditional designs. This is LME4, linear mixed effects models. And you can go there also. This is about the prediction, okay? But okay, this is the kind of like the introduction of MrBean. You can go to the web page and find more information related with the app. And if you want, you can download from here. Okay, saying that, now we can import some data. So this is the module for import data, for importing data.
Um,
Sorry?
Johan, can you increase a bit the font, the size of the text, so people can
Let me
see it?
know if something like this is better.
Maybe a bit bigger.
Yeah.
Okay, that's good.
Okay,
Thank
sorry.
you.
Okay. Okay, now we are here uploading information. So in the repo, you can find the first example. This is a single experiment that we have, and you can find the information about the genotypes, the replicate, the block, the row and column coordinates. And this, for example, is days to flowering. There are a lot of traits here, but we are going to analyze, for example, first only the yield in this case. And this is this data set is already loaded in the package, so you don't need to open. But if you want, you can import it like this. Only you have to select the import data, and then you can load your database. And also, you can import information from BMS. This is breeding management system. You can go to their website if you want, and basically it's for uh, getting data from this database. And you can use, for example, if you have the user, in my case I have this, and you can access directly to the data sets that you have in there. And this is the crops. In this case, I only have the possibility to open to this crop. This is beans, and I have to select what is the program that I want to, for example, in this case, to analyze, because there are, in our case, there are a lot of programs, and in each single program, there are a lot of trials. So if you want to select one of them, you can analyze it directly. For example, if you select this one, I would say this is an example. You can select it, and you can visualize the raw data directly. So, okay, if you want, you can use data from BMS, but if you don't, you can use, or we can use the data, the example data. So, okay, once we have loaded the data, we can go to descriptive plots. So in this case, you can visualize your data in the field. For example, this is the position of like the spatial arrangement in the field, and you can, for example, identify, for example, the genotype line, for example, and you can find where was located this genotype. For example, this was the replicate one, and this was the replicate number two. You can open or increase the windows if you want. And for example, the replicate, if you want to see what was the replicate, for example, the block effect, in this case, you can identify this is the block number one in the replicate number one, and this is the block one, but in the replicate number two. So this is using Plotly, as you might know. This allows you to create interactive plots. So this is something awesome that you can use also. And for example, box plot, if you want to identify like patterns that is affecting, for example, your responses. And for example, in this case, we can analyze the yield and see how is the behavior. And for example, you can see that this column, the 6, 7, and 8, they have higher values than the other ones in the streams, in the borders, I would say. And this is something that we have to try to model. So that's why it's necessary to use, for example, the spatial approach, I would say. And this is also like looking at the effect that has the row in our response variable. In this case, you can see something similar. Maybe there is an border effect, but we will see. Okay, this is for descriptive plots. Then we can jump to something related with the distribution of our data. You can select the variable that you are going to analyze. This is something only for, I would say, adjusting colors and the numbers, for example, the bandwidth. And for example, if you want to select, for example, what are the string values, you can identify them like this if you want. And for example, if you want to identify also for example, by replicate, the replication has an effect. This may be a question in the response variable. And summary statistics is related. This is related with the descriptives. That means mean, standard deviation, median, max, and all the stuff. And you can identify if there are differences or not in your data. This is for something like briefly, I would say, and related with the distribution, with descriptive plots, and all the stuff. So once we have everything like clear about our response that we are going to analyze, then we can jump to single-site spatial analysis. In this case, it's important to mention that we are going to analyze only one site. And for example, this is if you don't know how to, what is, for example, uh, what do you have to put in some specific field. So you can go to the guide, and then, okay, this is the response variable that you are going to analyze with the phenotypic information. This is the genotype, and the genotype, this is the name in your data set. For example, this is line, and this is something that you have to define previously, because If you take the genotype as a random factor, that means that you are going to to visualize blobs, and you are going to get blobs, and this is that you are taking the genotype as a random effect, and that means that you can get the heritability and also the variance, the genetic variability in for that specific trait. And in this case, we are going to take the genotype as a random factor, and we have to define what are the like the coordinates in the field. In this case, is col and row. And if you want to incorporate, include additional fixed factors, random factors, and also if you want to incorporate like a covariate, you can do it. And what you have to do here is to select the factors that you want to incorporate. For example, replicate if you want, block effect. But if you don't want, you can leave these fields like this, only blank. And then if you have everything like ready, you can run the model. And now we have to wait a little bit. Okay, speeding. And now you can visualize the summary of the spatial analysis. In this case, it's using the Splines approach. And if you want to understand a little bit more about this output, you can go directly to the paper, or instead of that, you can go to the manual. In this case, this is the response variable, the genotype. The genotype is or was taken as a random factor. This is the spatial component. If you include additional fixed factor or not, the random factor. And this is related with the number of observations, number of missing data. And this is something useful for comparing models, so you can use it for that. And this is the dimensions you can get. For example, in this case is the heritability. This is a ratio between the effective dimension and the nominal dimension, and all the components that you fit in the model. And okay, this is for the summary, and then you can go to the plot model, so you can see what is the raw data in the field, and identify some patterns. And this is the fitted data, the residuals, and the fitted spatial trend, you know. And this is the genotypic blobs. So in this case, the most important things are our blobs or our genotype effects. So in this case, we are showing in this plot the genotypic effects. And this is the histogram for the genotypic blobs. Finally, if you want to see, for example, the heritability, again, you can visualize like this. Residual standard deviation, the R square, it's kind of like a R square. This is the coefficient of variation of the genotype effects. And you can visualize the spatial trend, like in 3 dimensions, I would say, and identify like the pattern in your field if you want. So this is, as I mentioned before, this is using Plotly. If you want, you can go also directly to the code if you want to how to do something in MrBean. And you can go like for downloading the genotype effects or the predictions. If you want, you go to download prediction, and that's it. But it's important to mention that we have to check a little bit our residuals, and this is for analyzing the residual of the fitted model. So in this case is the residuals. We don't have extreme residuals. We don't have extreme residuals in this case. This is like the Coco plot. If you want to compare the residuals, I don't know, with another effect in order to identify possible factors that maybe they are affecting our responses. But yeah, in this case, we don't have a stream residual, so you can leave this like this. And this is the other model for visualize like the predictions. You can see, okay, this is the baseline, for example, in this experimental trial, or yield in this case. This is the predicted value for that genotype. You can identify what was the worst genotype in this case, and this is the intercept, and that means that is the overall mean for the predicted values. And you can download the prediction again by using this button. This is an interactive histogram if you want to play with this. And okay, now this is for analyzing a specific site, but I don't know if now Salvador has a better connection. If you want to add something at this point, and Rita, maybe
Yeah,
you
so
ask him.
yes, we will ask him. I think he is Salvador. Are you there?
Yes, I'm here. Can you hear me?
Yes,
Yeah.
I think so far yes. So let's try it again.
Let's try again. I'm going to try to share my screen again.
Mhm.
Okay, so
Okay.
Johan was talking about space, and I just want to give a little bit of a where there's two things that we do with the spatial analysis, and one of them is to model the gradients, the other one is to model the patches or the correlation between structures. The reason, can you hear me?
Salvador, yeah, so there are some moments where we can hear you and some moments where you are not. So try it again, see if it works.
Okay. So when the idea we have is behind MrBean is that there is two elements that we try to model
Yeah,
when we
it's a
do
really
spatial analysis.
it's a really nice robot effect.
To model the
So,
gradients,
but
and
it's
this is where
we
the
can't
science has
understand.
shown come into play. But there's other, yeah.
Yeah, I think like Salvador, there is like problem with the connection. There are problems with the connection. So,
Yeah,
John,
maybe
can
we,
you?
yeah. Now I can continue with the presentation.
Yeah, thank
Okay,
you.
Yes.
let me know if you can see my screen right now.
Yes, we can.
Yeah, okay. So this is for analyzing. So I was mentioning that this is for analyzing a specific location. And I I'm going to jump to analyze multiple traits, because yeah, before to go to the side by side analysis. In this case, trade by trade is for analyzing multiple trades by using the SPATS approach. In this case, is for a specific trial. So in this case, we don't have multiple sites. This is in the same with the same data set that we have on the GitHub. We are going to analyze but multiple traits. In this case, what you have to do is to select multiple responses, and for example the yield, as I put it before, we can put the days to flowering, days physiological maturity, and for example, let me see this one. And you select, for example, in this case, we have 4 responses. And again, what you have to select in the genotype, this is the name in the dataset. And as I mentioned before, if you are going to take the genotype as a random factor, or if you are going to take the genotype as a fixed factor. Um, the column coordinates, the row coordinates again, if you want to include additional fixed effects, or if you want to incorporate um, random factors. And this is something very similar as the module that I showed you before, but it's for only analyzing multiple threads by one. It's important to mention that because we are not analyzing this information by using a multivariate way. So in that case, it's a little bit different, but yeah, it's only for mentioning. And remove outliers. So if we find outliers in our response, so if you want to remove them, the outliers, you can do it like this. But okay, now we can run the models. So in this case, is feeding the spatial analysis for the first response. Then Mr.Bean jump to the second response, and so on. And when Mr.Bean finishes, now we can visualize each single trade. In this case, this is the trade that we ran before. This is the days to flowering. And again, it's the raw data, the fitted data, the residuals, the fitted spatial trend, the genotypic plots, and also the histogram for the genotypic plots. In this case, once we select the trade, we can visualize below the predictions for that specific trade. And this is using HART4. As probably you know, this is an amazing package that can help us to visualize interactively our data. And this is the predicted values and the standard error for each single genotype. Okay, this is the spatial plot. If you want to download or save the plot, you can do it. You have to select if you want to download the plot as a PNG or as a PDF, and then select the white and height. For example, in this case, if you put this one, you can visualize better in high quality, I would say. The, the trade. Okay, um, this is for the correlations. In this case, we can see uh, that there is not correlation between these trades, and this is NS means not significant differences between each pair, and this one is significant. That means that this physiological maturity is correlated with days to flowering. On the diagonal, you are going to find the heritability for each specific trait. And I have to mention that this is Pearson correlation. This is not, again, using a multivariate way. So this is only using a Pearson correlation for comparing the predicted values for each specific trait. You can download also the plot if you want. And okay, let's go to the summary. Okay, this tells you what is the genotypic variance for each trait, the error variance, the residual variance for each trait, the heritability, the numbers of extreme observation that Mr.Bean found, and the R square. This is pseudo R square, and you can find this is for comparing the response with the fitted data, only for mentioning. And this is for the predictions. This is, for example, if I put the first genotype that I have, and this is the predicted value for each specific trait, and the standard error for each specific trait. Okay. And if you want, you can download the table like this. Let me show you. This is the table like this. But if you want to have in a maybe in a nice way, you can split the table and then visualize only the, let me check, like this, the genotype and each trait, like this. This is my first genotype. This is the response or the predicted value for the yield, the predicted value for the days to flowering, and so on. You can find this better than the other option, but yeah, you have to choice. And this is potential outliers because, as I mentioned before, there are some extreme observations in each trait. So that's this window tells you about the extreme observation in your data, and you can see the days to flowering as one observation, one extreme observation is located in this position. This was the genotype. This was the response, or I mean the real value, in this case for the days to flowering. And for this is 100 seed weight, we have two extreme observations. And if you want, as I mentioned before, you can remove them. You have to select this, and then uh, we have to wait a little bit while Mr. Bean is feeding each specific trait. Okay. Now it's feeding days to flowering. Now it's feeding days physiological maturity. And when Mr. Bean found or finds an extreme observation, sorry, they remove the observation and then feed the model again. And now we can see that there are not extreme observations. So that is awesome. And then we can, like, if you want, only like download the table again without extreme observation. And yeah, this is for analyzing multiple traits. I have to mention this. And now I think we can jump to the multiple sites. And let me check something in these slides. Because, okay, maybe I don't know if Salvador is a robot, but yeah.
Yeah, let's try again. Just a question
Yeah.
into Salvador Khan. Uh, Basically, you guys with the app, it's everything's open. Then when you run the first time, and then your the app have this option showing which one is the stream values with supposed outliers, and then you can select those and remove those from your data set and run again, and then you have all new values again to download, right? Is
Yeah.
what, just to see if I understood. Yeah, that's super cool.
Yeah,
That's
yeah, yeah.
pretty neat. Pretty neat to
Yeah,
do.
because yeah, for example, yeah, it's something like, for example, complicated if you report, like, for example, the stream observation, but then you have to remove in Excel, for example, and then upload again the data set. So yeah, that
Yeah,
is
that's super
complicated.
smart.
Yeah, and
That,
then only yeah.
yeah, congrats. Yeah, and I really like the effects that you guys use. For example, loading,
Ah, yeah, yeah,
Yeah,
yeah,
I
yeah.
guess everybody that has some experience with Shine applications right now, observing your app working, see, wow, they did a really great job. I spent many years learning things there, and yeah, you guys, your app's super, super cool.
Yeah, and this is for special for people that are impatient. And you sometimes when you don't see like something that is loading,
Moving,
and you
yeah.
say, "But what is doing? What Mr. Bean is doing?" For example, what is doing Mr. Bean, and I don't see anything, and this is like stressful because but that's why I put like the loading effects on the screen. But this is something useful,
That's
very useful.
amazing. Yeah. I guess Salvador wanna talk something? Let me. Salvador?
Yes, I'm not going to share my screen and I'm not going to share my face either. Um, let's hope this one works a bit better. So Johan has shows us how you do a single site analysis, which works very nice. And the challenge is when we have to analyze lots of different sites together in using spatial statistics. And the problem is that when we try to analyze every site together, it's okay. But when we put everything together into the same analysis, which is an MET, we run into problems. Problems, can you hear me well?
Yeah, perfect.
Okay, good. So we run into problems such as, obviously, we have to estimate lots of variance components, correlations for each of the sites, spatial correlations for each of the sites, variance components for each of the sites. So that's going to be a complication. The other thing that happens is that the model is going to be a lot more demanding and is going to need a lot more computational resources to do. And finally, the last problem is we usually compare sites together
Yeah, we had a
Okay.
great time. Listen, Salvador. Right?
Are
So
you there, Salvador? No, I don't think so.
yeah, so maybe if he need, for example, one of us can share the screen, you know, uh,
Yeah.
and then I guess maybe you know where he's
Yeah,
talking.
Anna was saying that she can share the screen, the slides, and then he
Go.
talks. But I think he's having problem to
Yeah,
speak now.
that's the new world. We need to adapt to this internet channel
Mhm.
into all we can stay together again in a conference room.
Yeah, but I think this piece part is very interesting because I think he's gonna talk about the linear mixed model, which are very important in time reading. And so it would
Yeah,
be nice if he can, if
yeah,
he's maybe he can try to. Um, so no, he say like just continue.
let's.
So I think,
Yeah.
Juan, you are going to be the one speaking most today.
Yeah. So,
The-
Salvador. Okay. So I can continue if you want.
yeah, please. Do you want to share your screen?
Yeah. One
Okay.
second. And presentation, and then maybe Salvador was about to mention this thing that is related when we want to in to put in one analysis, in one single analysis, multiple sites. This is something very complicated because specific like components try to model each, for example, the spatial variability for each single trade, different, for example, splines for each specific trade. So sometimes it's complicated to put everything in a single experiment, in a single model. So that was is necessary maybe to try to put this in or separate, split the analysis in two stages. But after I mentioned the multi environmental trial, I wanted to show you how to analyze the information, but using ASRML because I didn't show you that. And for example, with this example, we can use it for explaining that part, ASRML. Okay, as I mentioned before, we use the Splines approach, the SPATs using Splines, and now we are going to use ASRML. And basically, uh, it's very similar with the splines that I mentioned. And what we have to select is the response variable, the genotype effect, if we are going to take the genotype as a fixed or as a random factor, the the coordinates in the field, in this case the column and the row. And as I mentioned, we can include the spatial correlation, that is using autoregressive correlation among the residuals. If we want, we can put this spatial correlation, but obviously we can play it with the data like this. Only, for example, left everything like this, leave everything like this, and then feed the model. And you can visualize in this case the spatial plot as is very similar as the previous plot. The diagnostic is related with the residuals.
Johan,
Yeah.
I guess you are sharing your PDF. Are you showing the app
Oh
or?
my god. Sorry.
It's okay. It's okay.
Oh my god. Sorry. Let me check. And let me now.
Yeah, here you go.
Sorry.
No, it's
Sorry
fine.
for that. Yeah, what I was mentioning was that the approach that I showed you first was the using splines. Now I'm going to show you how to analyze the data by using the ASRML. In this case, is including like the autoregressive correlation among the residuals. And what we have to do here is to select again the response variable that we are going to analyze, the genotype. If we are going to take the genotype as a random factor, or if we are going to take the genotype as a fixed factor. Okay. We have to select again what is the, for example, the column coordinates in the field and what is the row coordinates. As I mentioned, the spatial correlation, if we want, we can include the spatial correlation, or if we don't include the spatial correlation. We can include splines associated with the column, with the row, and also include additional factors, for example, by the column and row. But I was saying that we can play with the model like this, only like start fitting the basic, the more basic model in this case. You can see like the plot very similar with the splines that I showed you, and you can also download the plot again, PNG, PDF, and all the stuff. And the diagnostic is related with the residuals, and the cuckoo plot, the histogram, residual versus fitted uh, data, fitted values, and related with the information about the model that we fit. This is the like a kind of like the formula. This is the response variable. This is the intercept, the random effect associated with the genotype, the
Um,
residual. Sorry.
Johan, they are asking if you can increase the volume of your voice.
Oh my god.
No, no, don't worry, it's okay.
How can I do that? On my
No,
voice
you just
or
speak
only?
louder. You just speak louder.
Okay. 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 This is the formula that I was mentioning. This ID means that I am not putting like correlation among the residuals, and this is related with the variance components. In our model, we only have uh, the genotypic variability related with the genotype, and this is like additional component related with the only with the residual. And okay, we can start like incorporating like additional like sources. For example, the correlation among the residuals include a nugget effect in the residuals. And this is the residual trend. For example, you can see how it's like a modeling the spatial trend. In this case, we cannot expect that our residuals.
Johan,
Yeah, sorry.
could you explain what nugget effect is, please?
So it's a little bit complicated, yeah. maybe
Okay.
Salvador can help us. But yeah, this is an additional because this is something more related with spatial analysis,
Okay.
and it's before, yeah, it's like an additional source of variation because with the spatial correlation among the residuals we can model something, but the nugget is an additional effect that can help us to model everything. In this case, the nugget is also called like independent residual.
Okay.
So if you want to include the nugget, and this is something important that we have to mention is that um,
Yeah. Thank you.
yeah, it's the goodness of fit statistics, because if we want to compare models, we can use them for, yeah, for comparing. And yeah, you put the nugget and you leave the nugget, and then you compare the goodness of fit statistics. You can put the splines and all the stuff. Fitting is remote model. And in this case, there are like many ways to analyze this data. Maybe you can find this complicated, but that's why uh, we put like a model selector. In this case, you have to select the response variable, the genotype effect, if you are going to take the genotype as a random effect or as a fixed effect, the column and row. And what you have to do right now is to like check, and then it's like starting like a modeling around 30, 33 different models, and then um, MrBean is going to tell you about what was the best genotype. In this case, this could take uh, time, so maybe it's complicated, but yeah, we can do it. Or if you want to play with the app later, we can do it like that. And this is by using a remedy. In this case, there is also the option for analyzing unreplicated experimental trials or augmented designs that has something like particular, and we have to take into consideration that in this case our data is not unreplicated, that is not augmented, but we can check uh, the this model like this. Um, if you have checks, for example, because most of the time when we have augmented designs or unreplicated designs, we have some checks that we can like split to the other genotypes. So that's why if you want to select what are your checks, you can do it like selecting this. And what is this model doing is to fit only four different models. In this case, is independent correlation, correlation among only one direction, for example, column, and then by row coordinates. And but you can also, in this case, is including the correlation between or among the row and column coordinates. This is like the interaction, and you can visualize what is the like the better. You can select, for example, yeah, I want to run this one, and then you can like kind of like see the residuals, the fitted data, the raw data, and also the diagnostic related with the residuals, the histogram, the cuckoo plot, and related with the various components again, and also with the formula that we use for fitting the model. The semi-variogram again related, and if we want to, yeah, only like, for example, run this model, and you can see what is happening, like kind of like a behind on the formula, what is MrBean doing. And okay, so this is for unreplicated or augmented designs. So if you have this kind of experiments, you can use this model. And now I think we can jump to multiple sites. In this case, you can go to the second example, I would say, yeah, the second example, MET, and then download this dataset. I have already downloaded, so I can go to this one. It's this one. Let me check what it's doing right now. Maybe it's feeding.
Just so you,
Yeah.
Johan,
Sorry.
you have one question here. I guess
Yeah.
you're ready.
Sorry. Sorry.
Yes, here you go. Are you reading the? Hi, is this software ready, available?
Readily?
Uh,
Yeah, of course. You can go to, if you want, I can show you the GitHub and also the web page.
Okay, yeah, is those links that we put here on the description, right?
Yeah, right.
Okay, so yeah, we have all this description here in this video, so go there, and it's explaining how download the app, but it's totally free. Yeah, there is this part, the IS remote part, that you need a license, but the app per se it's free
Yeah.
and is available.
Yeah,
uh,
and even if
and
you don't
remember
have,
that if you are a student, you can have a Scrabble 1 year free license. So just want to say.
yeah, and even if you don't have like ASRML, you can play with the app, so it doesn't matter. Only what you is not going, what you are not going to be able is to run the ASML like modules, MET, augmented designs, and also spatial analysis by using the autoregressive correlation among the residuals. And okay, and now I'm going to share my screen again. Okay. This is the GitHub. If you want to go, this is Friday hands-on, and this is the GitHub for the package. If you want to go there and the installation steps. Okay, so once we uploaded the information, loaded the information about the MET, we have in this case we have around 13 experiments, and what we are going to do is analyze in using the two-stage approach that maybe I can mention. But first, I want to only like run the side-by-side way, in the side-by-side way. And we are going to select, in this case, we are going to analyze again the yield, in this case, the yield. And we can jump to side-by-side, and then we select the response variable, the genotype. In this case, I have line number 2. The genotype, if we are going to take the genotype as a random, as a fix. In this case, I want to take the genotype as a fixed factor, because we are going to go to a MET. So uh, the methodology that we have in the application is a two-stage approach for analyzing multiple environmental trials. So in the first stage, what we do is analyze each single experiment, yeah, like this, each single experiment separately, and then we put the stack all together, and then we analyze them by using the ASML on incorporating different structures for modeling the G by E, the genotype by environmental pattern. In this case, we have the response, the genotype.
Joan,
Sorry.
there is another question for you. Oh,
Yeah.
So he's asking, can we apply different CV schemes in it?
I don't understand the question. CV?
Yeah, I think like Fabi is referring to the scheme of the field.
CV schemes? I don't know. Maybe Salvador can help me.
Yeah, maybe I will ask him what does it mean for.
I don't know. Yeah. And okay, I'm going
You can go ahead and then if he I will.
to. Okay. Can you see my screen right now? Can you see my
Yes,
screen?
yes, we can.
Oh, okay. Okay, sorry. Okay, in this case, we have to select the response variable, the genotype. In this case, the experiment is the variable in your dataset that is split each single site. In this case, is dataset, color and row dimensions. In this case, the coordinates and info about the experiments. So it's necessary to check like previously, like each single experiment, because for example, one of them doesn't have observation maybe, or doesn't have column and row coordinates. For example, in this case, each single trial has column and row coordinates in this case, and we have observation. We have some missing values, but SPATs and also REML can deal with. Okay, so this is the number of missing values in each for the response that we already selected. And this is the data set, and the number of column that we have, the number of rows that we have, the number of genotypes. And now we have everything like clear. We can like include additional fixed factor, additional random factors, and also if we want to include like a covariate. And for example, if I want to put this that is plant harvested as a random factor, I can put the factor and select the experiment that I want to apply. In this case, I want to put this effect for each single site. So now I can continue. I have the response, the genotype, the genotype as a fixed factor. Everything is clear. Everything is okay, I think so. And then this is the number of genotypes. So under the mixed model approach, so it's not like necessary to have uh, all the genotypes in all the experiments. So that's why this plot looks like this, because in this case, for example, we have too many genotypes, and in this one is less, you know. And the number, this is the shared genotypes. You can see like on the diagonal the amount of genotype in each specific site, and the number of genotypes, the shared genotypes between each pair of trade or trial. And now we have everything like okay, we can run uh, the models. So initializing, so in this case, it's important to mention that we are analyzing every single experiment like individually. So what MrBean is doing is analyzing or applying a spatial analysis using splines in each specific level, in this case, in each specific site. Okay, so while MrBean is feeding in the models, in this case, we have 13 experiments. So I want to go to this, because once we have everything like every single site like fitted, what we have to do is to save the predicted values, and then something related with the weights that they allowed us to run the second stage, that is for connecting everything. And let me check if it's running. Okay, now it's feeding this one, 18. Okay, now we can go to check models and visualize the results. The residual variance for each specific trial or site, I would say, or experiment. This is the residual variance. This is the correlation, but this is using like, um, in this case, I'm not using a covariance variance structure. So this is only like a correlation, Pearson correlation between each pair of site. This is the summary. As I told you, as I mentioned before, this is like a kind of like the experiment, the variance residual, the residual variance, the editability. In this case, we took the genotype as a fixed factor, so that means that we are not be able to get the editability. In this case, the number of outliers, the R square, and the predicted values. You can find in these predictions, a weights. So these like these weights uh, help us to run the second stage in the MET analysis. You can find there are two streams observations. So if we want to remove them, we can do it. But if not, so we can leave this like this. And okay, this is a side-by-side analysis, so you can visualize each specific experiment, and like that, like see what is like the summary for that specific um, response variable in that specific site. And then, so what we are going to do right now is to save the results. So the predictions, this is the predictions, and then we can save them. Save the predictions, and I'm going to save them in example. I'm going to put to stage MrBean. And this is exactly the same data set that I have here. Example number 3, predictions to stage. And okay, once we have everything like okay in this model, we can jump to the two-stage analysis. In this case, what we have to do is to import the data from the first stage. So in this case, we can go to our folder, then upload the information. But after I run this, I have to mention that for modeling the G by E, there are like kind of like a different structures that we can put for modeling the interaction between the genotype and the environment, or I mean the site or location experiment. And we can assume that we have like only one single like variance for each, or we have the same genotypic variability for each single tribe. That is something unreal, I would say, but we can like go to more complex variance covariant structures. So we can model like diagonal core H, and also related with factor analytic. That is another way to, or a different way to model the un structure that this allowed us to put a specific genotypic variability for each single site, and also a covariance between each pair of locations. So this what Mr. Factor Analytic tried to do is to analyze the G by E by using like a more parsimonious model. And so as I mentioned before, what we did was analyze each single try, because each single try has its own design structure, so that's why it's necessary to fit each single. And now what we have is the second stage. We are ready for the second stage. And we select the predicted values. In this case, we are analyzing the yield, and these predicted values are for the yield. The genotype, in this case, is the line number 2. The genotypes, we are going to take the genotype as a random factor. The experiment, in this case, experiment. And if we want like kind of like analyze only 3, 4, only a subset of the experiment that you have. But in this case, if we want to analyze everything, we can leave this like this. The weights, remember that the file that we saved before uh, had weights. So in that sense, we can put the weights in this field. And this, the last like input, is related with the covariance structure. And okay, we can put like core B structure, core H structure, and factor analytic structure, and a different factor analytic number 2, number 3, and what else? What else? Core H, that is very similar to us, in this case on structure. And in this case, I'm going to put the factor analytic structure. And now we are ready for analyzing everything. Okay, but we are going to see.
Uh,
Sorry.
Johan,
Yeah. Sorry.
hey Anna.
Hey,
Hey.
I just wanted to say something important. So up to this moment, so Johan has showed the capability that Mr. Bean has to do analysis for single location analysis, and we have seen the different ways that we can do it, either with um, ASREML, right? And also how we can do it with the other software that is SPATS or the other package, right? But I just want to mention that like he is going now into the multi-environmental trial analysis, right, Johan? And then right now what we are doing, or the approach that we are using with Mr. Bean, is doing a two-stage analysis. So we do the analysis first by location, as you saw initially, and now we are going into that second stage analysis. So we are going to feed the information that came out of that first analysis of each by location analysis, and that's why he has those weights in there. So go ahead, Johan. I just wanted to make sure like we had that being said. Thank you.
Okay. Thank you, Anna. Thank you. Thank you for that. And now I will continue with this. Okay, this is multi-environmental analysis with ASRMLR. In this case, we have to use ASRMLR. And okay, and we can visualize the number of genotype by each experiment, and the number of shared genotypes between each pair of experiment again, and the means and their standard errors. And now we can like run the model. In this case, I have to mention that I'm going to analyze my data using the factor analytic structure number 2. And now we have to wait a little bit, and now we have it. The model, the number of variance components, the log likelihood, the AIC, the BIC, different criteria. And we can jump to this. Okay, now here we can like, this is the covariance matrix that we get. And if we have the covariance matrix, we can have the correlation matrix only with some math that we do. And with this, like the correlation matrix, we can we can have something like kind of like a dendrogram in order to visualize like different the G by E. I mean, in this case, we can see that there are two clusters, and it's basically related with location. In Colombia, we have in this data set we have this location, Darien, this is Palmira, and this is Quilichao. And this is showing us exactly like the G by E that we have here in Colombia, in this case in beans. And you can identify this, so that means that there are like, kind of like a cluster. The genotypes like have a behavior in this location, and the genotypes have like a kind of like a, the other behavior in these others. And you can play with, for example, letter size if you want to do it, line size if you want, horizontal, vertical configuration, like put it like boxes in the clusters. You want to create kind of like more clusters. And if you want, you can download this plot if you want to save the dendrogram. And this is the residuals, because we are feeding like the model in the second stage. This is related with the formula associated with the model. In this case, the response, the intercept, the trial, and the factor analytic, the interaction, the G by E, I mean, using the factor analytic structure. We are using like the weights, in this case, weights. This is the this is the weights, and this is something that we have to put like this in order to fit the model. This is the number of variance components. In this case, we have a lot of variance components because we have a lot of experiments, you know. Okay, now we have everything like this. This is like the predictions. This is the predicted value for each genotype in each specific trial, in each specific experiment. We can save the prediction, and but if you want, you can like kind of like a compare different structures. You know, for example, the diagonal with the core B, for example, if you want to compare two different structures, what is better, and then you can select, okay, this is the covariance structure that I am going to use for fitting, for modeling my data. You can play with this if you want to compare models. And this one is related with the PCA, because if we have like the predicted values, we can have like kind of like a B plot related with the genotypes and also with the locations. The B plot, you can see like the locations. Darien is a different location, and Palmira is a different location, but they have a positive correlation among them. So this is something important because all the arrows are like in the same direction. So that's something very important to take into consideration. This is only for like visualizing only the variables, and this is for visualizing the genotypes. In this case, we have to we can identify, for example, that this send is the best one. This one is kind of like the second one, and so on. These ones are like worse. Um, like this is like the PCA for the predictions, but when we use a factor analytic, we can have something very similar. But yeah, I'm going to show you after this. This is the G by E. In this case, we have to select, for example, a specific genotype, and then visualize what is the behavior in each specific site. If you want to see, for example, this one in this location, what was the predicted values? In this case, we have negative values because it's only like kind of like at the blob without the mean, so it's only like the blob without the yeah, the intercept for each specific trade, right? And you can see, for example, and search a specific genotype that you are interested on. And if you want, for example, select only this one, for example, this was SMC Quilichao, and this one was SMC in Palmira, so on. And as I was saying, we can jump to the factor analytic. We have a lot of things foreseen in this approach. Is in this case is the genotypic variance for each specific site, and the variance explain it. Because in this case we are analyzing the data using a factor analytic structure 2. In this case we are incorporating, this is something very similar with a principal component analysis. You can incorporate like more components, but if in this case, for example, 2 could be enough. And you can see like the percentage of variance explained for each single site. And this is, for example, the percentage of variance explained by the two factors. So in this case, is very good. This is very similar with the vplot, with the PCA, but in this case, it's using scores. Scores are related with the genotypes, and loadings are related with the locations, with the experiments. In this case, if you want to find a specific genotype, you can do it like this search. Okay, this is my genotype. This is my genotype. And for example, if you want to search a specific location, this is Palmira. And again, you can see like kind of like at the cluster, this is Palmira. This is the other location, Quilichao. This one is related with Darien, and Darien. So, but they are like in the same direction, like my right hand, I would say. So that means that they are positive correlation among them. And this is something that I showed you before. That is because we have a positive correlation. Everything is positive. We don't have red values, only blue values. And okay, this is related with the loadings for the for each specific site, and this is the score for each specific genotype. Okay, now we can go to the latent regression. This is very useful when you want to compare two, for example, genotypes, I would say. And for example, we are going to take this one, and we are going to take this one, for example. Let me check like this. This looks like, maybe I would say that this is the best one, and this one is the worst. Yeah, I would say something like that. And I can visualize this using the latent regression. And what I have to do is to select what is the, for example, genotype related, and what else, strain this list. So now you can identify that this is a SEN 56, and this is the other one, and you can like compare them using the factor analytic capabilities. You can check, for example, the labels related with, this is Palmira 18, in this case, Palmira 15, Palmira 18 irrigated, because they are in different conditions, stresses, and in this case, Darien, and you can see that in Palmira, this genotype is better than in Darien. and in this case is related with NUA, and has, I would say that, worse values for Palmyra and better values for Darien. And you can do this for comparing 2 or 3 genotypes if you want. It's like kind of like a line to beat. So if you want to play with this, you can do it like this. For example, we can put something like more stable, I would say, like this. This is a genotype, and it's like kind of like a more stable in each specific location. So it doesn't matter where was located that specific genotype, because this has kind of like the same behavior in each location. And if you want to download something, for example, related with the loadings, with the variant explained, you can do it like this, copy and paste in this case if you want to see. And this one, for example, you want to download the image, or if you want to download the data that you are visualizing. For example, in this case, you have a button also for downloading scores, for downloading loadings, and what else? Data view and all the stuff. Yeah. And this is for the MET analysis. So I don't know if Salvador want to include some additional remarks. If you want, Salvador, how is your internet connection?
Yeah, actually, he sent a message that not. He
Uh,
say that you're doing a really great job.
okay. Okay.
You
So
wanna
yeah,
continue?
I think, I don't know if Anna, do you want to add something at this point?
Definitely. Well, thank you very much. I think that this is great, Johan, and just wanted to say, like, with what you showed there, pretty much all the functionalities that MrBean has, and then for all the people that was having some questions, maybe we can start answering those questions now.
Yeah, there is one question that just popped up. So he's asking for the multi-location two-stage analysis. Will MrBean analyze only one trade at a time?
That is correct. It will only analyze one trade at a time.
Okay. Yeah. So I don't know. There's been just one question so far. Like,
Okay. Well, you say that there were some questions regarding licensing, didn't you?
yeah. So I answered, but if you wanted to repeat them, like maybe you know more about me.
Yes. So then with regard MrBean, so MrBean is a free package, but the portion that contains the ASRML licensing, that you need to get a license from ASRML directly. So I'm going to share my screen really quickly and just kind of like to give you the heads up. So just go into the VSNI website, and then you go there. You can go directly and, like a well, it say here free ASMLR4, but then that only will be for the people that is in the medical research because of the COVID-19 right now. But you can contact them directly in here, and then you can see like pretty much in there you can put your information, and they can you can message in them. Also, if you go directly to the software, then you can browse their products, and then you can find directly the ASMLR. You can discover more in there, and then you can just kind of like get a quote or download the ASRML if you already have the licensing. So that is regarding with that part. Is there any other questions that we have in the chat?
I have some questions into some more questions from the people that is following here. Actually, for example, in the book that you guys said that is organizing, you're gonna start with some point from residual evaluation first, for example, data description, and then you come from the residual, like showing a pipeline that the user could follow and use your app to get the final results, right?
Correct. So then we will have the book that we will have, or that will accompany be the companion of this product. It will describe like from how to upload your data, how to get, like to do the quality assurance, quality check. Then it will go through the process of like, okay, how do you do the side-by-side analysis, or this the one-side analysis, the multi-environmental trial. So far, like the product is very customer centric. We believe that is pretty easy to use. Once you get to put your fingers in it and start clicking in, it's going to be super easy. And also, for those people that, like they would like kind of like to use more kind of like to see what is in the background. I wanted to show these, Johan. Let me know if I'm doing a good job. Is you can call it directly from R. Like if you want to see what is going on in there, you can just say, okay, I put library MrBean and I run the app, and then this will bring automatically the web application. So that would be for those people like want to see what's going on in the background, right? There is other people that it will be like, no, I don't wanna do that. I just want to click on my link on the desktop, and I just want to open it, and that's it. Voila! I don't want to see anything in the background, right? So then that's the flexibility of MrBean, I would say.
Yeah,
So
that's great. And one addition, this is a fantastic tool for teaching.
it
For
is.
example, when you
Yeah, exactly.
are, right? When I started to work with Shine, it was more related for teaching or making easy to understand some concepts in genetic. And then now statistics is amazing. Like it's easy because you guys put also the data as example. Then we also did this with super cool and help. Then the teacher or professor, they just go there and they want to explain like single trait or mood trait and environmental, and then they have the example, and then the student go clicking and then see the output like Johan explained pretty well.
Mm-hmm.
And yeah, and also the interface is really great.
Yes, definitely. And I think that, one of the things that I, wanted to share that maybe we didn't did at the beginning is like when you upload your data and you can see it in there, you go to the import data, and then you browse for the file that you are looking for. In this case, it's this experiment in here. Like I have 3 locations in this particular data set, and then you can just say, okay, I have a CSV file, so my missing value character is NA in this case, and the type of character or separation is comma. Then you can decide like, okay, if I am going to be doing the initial analysis, you just go and select the subset, like at the variable that in this case is the experiment, right? And then you can see in there that I have 3 locations with that same experiment. It's Carrington, Fargo, and Prosper, right? So then that's the cool part, that like you can be connected to a database, you can be importing your data, you can go and use the SPAT side or for the single site analysis, or you can use the ASREML side. Like in this case, this particular experiment is more like an unreplicated type of design. So then once you do that, other thing that I wanted to mention, like pretty much Johan showed the capability of the software, kind of like when you click these drop down menus and then go and look at for your variable. But you can also write your variable. For example, I put in here yield, and there it comes, right? If I want to say, okay, my genotype is name, there it is. And then you can select, oh, my column, like how we call it P range. And my row, we call it P row. And then don't get confused by that, but like it's just the lingo of our database. So we can, once it do that, like, we feed the models, right? And then it's doing pretty much what I'm asking it to do, unless if it gives me an error, right? So then I can go back and see what did I do wrong, right? So then you can say here, hey, I didn't select which level. I was saying that I have 3 locations and I'm doing the side by side, or like I am doing one location at a time, so I can select Fargo in this case. So that's what I wanted to show you, not only the connection side, but also the importing, right? If I go into the unreplicated, I can do that again. Go ahead.
Anna, there are 2 questions, one
Yes,
Anna
please.
and John. So the first one is like Carolina. Hi, great package. Is the confidential data secure if I use the package?
Yeah,
Yeah,
it's
definitely.
confidential. Definitely, yeah.
You need to download it into your computer so you don't
Yeah.
have, any uncertainty, but yeah, it's confidential. Yep.
Yeah, because it's just an open, like, so it's still, you are still working on your computer.
Yeah.
And so
Correct.
it's just launching, like, so the page that you have is that, but still you are using the CPU of your computer. This is why
Correct.
we ask to download the package on your laptop, because then you are not in a server. So yeah, it's like if you are working on our studio, but instead of knowing the language that you have to write, you can just like go there and it's easier because there are windows. So I think the cool things of Mr. Bean is that you don't need to know R, basically. You are
Very
just
good. Yeah.
going there and do what you want to do. So there is another question, but then I have one question also, like, so then like how big can be the data that I can manage? Like, if I have like how many individuals can be in the trial? Is there a limitation on the size of the data that because sometimes in a breeding program you are dealing with thousands of individuals. Is that an issue, or I can use like there is no problem? Like it depends still on the CPU of your computer and how much memory can manage your computer.
So maybe I
Go
can
ahead, Johan, please.
that question. Yeah. So related with the size of your file, there is a message that tells you that you can only like the full max, like the file is size is
Mm-hmm.
5 MB. So in this case, I can change that option because it's something that Shiny allows us to do. But yeah, in this case, we have only 5 MB, but I can change it. Yeah,
Okay.
and I didn't realize before.
Yeah, no, it's like I think it's important. So because sometimes you have, like, let's say you have a phenomic data, many times with the camera you have like many observation, and you many indexes, and you want to know, like, maybe you have a very huge file. So I think it's important to know that you can set the memory, and of course depends, I think, the power of your laptop, the CPU and everything. There is another question, which is a practical question. So he's asking, will you show how to download and install the desktop app?
No, we didn't do it, but maybe I can show you.
Yeah,
Like, if we
it's very
do
easy.
we have time? Do we have time to show you?
Yeah, that we have like 10 minutes, so you can do it very quick.
Okay, let me know if you can see my screen right now. Yeah.
Uh, yes, but you have to, yes, you can. Yeah.
Yeah. Okay. So what you have to do is to create, in this case, is a bat file, and in the bat file you are going to write this. I don't know if you can see, or is let me
Maybe, yeah, you should increase the,
increase. Yeah.
yes, yes.
Can you see it? Yeah.
I
This
think
is
it's more clear now. Mhm.
yeah. Now it's okay.
May,
What you have to do is to
Johan, maybe then you can share this link later in the comments in the video.
yeah,
Okay,
exactly, yeah.
good.
And also on the GitHub I can put it like this.
Okay,
But yeah, mainly is to define where is located your art, and then you have to put this like the URL like this, and we have to create another file that is related with these two lines. Is basically library. You load the library MrBean and then you run it. But the most important thing here is that you don't have open. It's like kind of like a hidden. And yeah, when you put or create this file and then you copy and paste as a, sorry, let me check, copy and paste as a shortcut, and then you put like MrBean, and then what you have to do is to change only like the icon, I would say. And yeah, let me check like this, desktop and MrBean and the icon, and that's it. Now I have MrBean, and I can open this only like clicking on it and this. then it's going to appear like a running MrBean, and then you can visualize something in your browser like
So
this.
then basically the comments in R are just the first time,
This
or
one,
no?
this one, and this one. Sorry.
So basically, the comments that you also type on R, they are like just for the first time, or it's another way to launch the app?
So no, it doesn't matter really. I don't know if I get
Yeah,
your point, but yeah,
yeah,
this
no. Okay,
only, yeah.
that's
And yeah, maybe I can show you or share with you this the code, the commands, and in the same repository that we have, Fridays on hands-on, and yeah, maybe here I can put the commands and how to do it by yourself.
thank you, John.
Okay.
Yeah, so so far there are no more questions. Okay, so I think we are. So if I'm gonna say this, like, so thank you to the speakers. We are sorry for Salvador that it couldn't make it, like, because of bad connection. But we want to thank you to show us this very powerful app. And of course, I want to say to the people that if you guys have any question, you can contact Johan or Anna, or like also like, so do you guys, if you want guys to be part of the Slack channel, maybe it will be also another way to contact them there. And yeah, so thank you so much for presenting. We have like 4 minutes, so maybe we can conclude and go ahead.
Yeah,
So
thank you.
thank you
Thank you,
guys.
guys.
Thank you. Thank you for inviting us. And then just thank you, Johan and Salvador, who had tremendously kind of like make this product what it is right now. And particularly in our programs, we have been applying it to several of our breeding programs. So we are very happy.
Yeah, people are saying that it's a very great app on the YouTube. So
Great.
gonna
That's
be
fantastic.
Thank you
So
so
thank you.
much for inviting us. I'm really happy to be here today. And
Yeah,
yeah,
and
if you have any question and any other things, please let us know. You know.
Mhm.
Thank you so
Yes.
much.
So Felipe, maybe we introduce the next speakers.
yeah, yeah.
I'm gonna share the screen. Okay. Yes, it's here. So yeah, so we are here. We are already at our first workshop. So we are almost half of our journey. The next workshop is still next Friday. Same time, same place. So the speaker will be India Johnson. She's a geospatial developer, and she's going to present OpenDrawMap, which is an open source solution for basically, I think, for orthomosaic images, right? To build orthomosaic images that you can get with a drone or any other tools. So yes, you can register at the same link. Of course, if you are already registered to the other workshop, you don't need to register again because we have already your email address, and then everything is like, so you are now a database. But of course, if you want to share this link with your friends and anyone that works with drone images and is interested in building orthomosaic images, it's a good opportunity to learn how to use this tool. And yeah, and so follow us on our social media, and thank you for being here with us today.
Yeah, thank you, guys. We had a great time, and hopefully see you guys next Friday here to help us to send this information out, and send us also some comments, send us like suggestions for other workshops, and let's working together. See you.
Yeah, bye.
Bye.